Have you ever wondered how you can prove that you've done your work without a shadow of a doubt? Like, how can we be sure that the results are correct and trustworthy? Well, there's this super cool thing called Merkle roots that does exactly that. Let me show you. Picture this. You're working on some calculations, and you want to make sure that your results are 100% correct. So you run them through the PoB Receipt Field, which is like a special tool that uses Merkle roots to verify your computations. The cool thing is that this process is completely transparent, meaning that anyone can check your work step by step. But what if you want to take it one step further and make sure that your work is also verifiable? That's where Merkle roots come in. Here's how it works. First, you take all your calculations and hash them, which is like a fancy math operation that turns your numbers into a unique string of characters. Then you take those strings and put them in a special data structure called a Merkle tree. This tree has a bunch of properties that make it super useful for proving and verifying work. Like the fact that it's append only, meaning once a node is added to the tree, it can never be removed or altered. And it's also sorted, which means that the order of the nodes in the tree matters. So let's see how this works in practice. Let's say you've done some calculations and you want to prove that they're correct. You can use the PoB Receipt Field to generate a Merkle root hash of your entire calculation. Then you can include this Merkle root in your PoW solution. Now, anyone who wants to verify your work can do so by following the Merkle root back up the tree to the original data. This allows them to check each step of your calculation and ensure that it's correct. And that's not all. This also allows for collaborative work, where multiple people can work on different parts of a calculation and then combine their results together. Merkle roots make it possible to combine the results of multiple verifications into a single verification. This is because each node in the Merkle tree represents a hash of the data, and the Merkle root at the top of the tree represents the hash of all the data. By hashing the Merkle root of the left subtree and the Merkle root of the right subtree, we can generate a new Merkle root that represents the hash of both subtrees combined. This process is called aggregation, and it allows us to verify large amounts of data with a single hash. In the context of collaborative tech, this can be used to combine the results of multiple verifications into a single verification. For example, in a supply chain, each node in the Merkle tree could represent a hash of data associated with a particular product at a particular stage in the supply chain. By hashing the Merkle roots of the subtrees corresponding to different stages, we can generate a Merkle root that represents the hash of all the data associated with the entire supply chain. This allows us to verify the provenance of a product by following the Merkle root back down the tree to the original data. So there you have it. PoW receipt fields and Merkle roots provide a way to prove your work while maintaining transparency and trust, eliminating fraud, and building a reliable foundation for collaborative tech. Comment below with your questions about Merkle trees and we'll send you the math. Stay tuned for more.